All right, welcome everyone to today's panel discussion talking about the Residential Energy Code for the Illinois Energy Conservation Code. Today's panel will take approximately an hour and a half. If you do have any questions for the panel, towards the bottom of your screen, you should see a Q&A function that you can go ahead and open a Q&A pane and go ahead and type your questions in there that you may have for the panel. So we can go ahead and answer those today. Today's presentation is being recorded and that recording will be posted to our website following today's discussion. So a little bit of background about the Energy Code presentation. I do want to thank all our panelists for joining us today, Katie, Sean, Leonard, and Don. As noted, we're an hour and a half, so do go ahead and start putting in your questions for the panel, and we'll go ahead and get into those before too long. A little bit of background about the Energy Code program. The Energy Code program, I'm here from the Smart Energy Design Assistance Center, or CDAC, and we are housed at the University of Illinois at Urbana-Champaign. We're also part of a public-private partnership with 360 Energy Group out of Chicago, Illinois. And our primary mission is to reduce the footprint of Illinois and beyond. So Energy Code training is part of the way that we do that. So do want to thank our sponsor, the Illinois State Energy Office, housed at the Illinois Environmental Protection Agency. They are sponsoring the training for today, so we do want to thank them for their participation. As far as our Energy Code program, we do have a technical support line, which can be used by building owners, occupants, design professionals, code officials, and anyone else who may be involved with projects here in the state of Illinois. So if you do need some technical support or need some assistance, feel free to reach out to us at energycode@cdac.org, or we do also have an 800 number that you may use as well. We do have several online resources at our website, cdac.org/energy-code. Some of those include archived versions of previous workshops and webinars, along with some online on-demand training courses. Those take approximately an hour to an hour and a half to complete. Also links to our technical support line, as well as frequently asked questions and many other useful websites, which also includes things such as links to the Illinois Energy Conservation Code, the International Energy Conservation Code, and the City of Chicago amendments to the code. So today's program is part of a series of workshops. Something that I do want to call your attention to today is covering residential code panel. And then we also have one covering commercial code coming up on June 15th. Also, we do have a case study and some lessons learned coming up here next month, February 24th. So do encourage you to register for some of these live, less scripted programs. So if you do have interest in that, please feel free to go to our website. Again, cdac.org/energy-code to find more about that. So with that, I'm going to go ahead and let our panelists introduce themselves and give a little bit of background. Let's go ahead and start with Katie, if we would.
Hi, I'm Katie Spurl. I am a licensed architect in the state of Illinois, graduated from the University of Illinois. I worked for an architect for about 18 years before I switched over to code enforcement, and I currently work at the City of Naperville as a code official.
Thank you, Katie. Next up, we have Leonard.
Hi, my name is Len Sierra, and I am an architect in Illinois. I do both commercial and residential. I'm also chairman of the envelope portion of ASHRAE 90.1, which is the other sister code to the International Energy Conservation Code, and we work a lot. The ICC and ASHRAE work together to align the two national codes to keep, in general, the goal is to have both codes be fairly equal in stringency. So there's a lot of back and forth between ASHRAE and ICC in terms of proposals and whatnot, and to balance all that. So I'm a code writer, I guess you could say.
Thanks, Len. And next up, let's go with Sean.
Hi, my name's Sean. I am not an architect. Actually, on SLS Construction and Building Solutions, we help people out with the code compliance, design of their projects, and the testing. Do everything from HERS rating, Energy Star verifications to just the simple blower door test. And been doing this since 2009, 2010.
Excellent. Well, thank you, Sean. And next we have Don.
And we hope my microphone works on this one, I hope. Don Plass, I was a builder, and then I ended up going into code, and I spent 20 years as a director of code, and I retired, and now I'm working in HR Green, a third-party consulting firm, and they use my expertise in sending me to different municipalities to work on things. I was one of the original council members for the Illinois Energy Advisory Council. I'm still on the council, even though I've gone out of municipal work. The Capital Development Board asked me to stay on. So, and we're going to be getting on. February is when the 2021 Energy Code is going to be published. And we have 18 months here in Illinois to be able to put any amendments to it and then get it to the stage where it's enforceable.
Excellent. Well, thank you, Don. And that actually led into a frequently asked question that we've answered a few times here. As far as we've had several people asking regarding the 2021 IECC and when will that become effective here in the state of Illinois. So it looks like we're probably looking at summer of 2022 here for the state of Illinois for that code. So there's a question to start here. Again, anyone in the audience who may have questions for today's panel, please do go ahead and put those in the Q&A box towards the bottom of your screen. And we'll go ahead and take those from the audience. So to get started, a thought from our panelists as far as how can architects, builders, and code officials look to support each other in code compliance, and what are some best practices that you have encountered in your practice? So who might like to start here first with that?
I can go ahead and start. Just as a code official, I think something that we would like to see happen more often is the coordination between the different entities. So perhaps there's an architect working on the design of a home. There's a contractor that's going to build the home, and then there's most likely a third party that's producing the manual J. We often find that maybe the manual J and the architectural aren't getting together early enough. And when we get the documents, nothing is matching. I think that's for us one of the largest struggles.
I would say communication, just like Katie was saying, to be able to get on early, and whether it's a residential small house or if it gets to a commercial project, being able to sit down and talk and get things started on the right track. And originally, it seems to go much smoother.
Yeah, Len and Sean, that'd be interesting. Have you observed a lot similar to Katie as far as what's built is not necessarily what was on the plans, and things not being coordinated as the program moves?
Yeah, well, one of the problems is that most houses are designed by architects, but the mechanical system is installed by the general contractor. And so most architects don't hire, in commercial buildings, there's typically a design engineer that is responsible, and they're under contract with the architect. So there's a lot more communication between the architect and the mechanical engineer. On residential projects, we just don't do that. They're perceived as being simple enough that, we sort of design the house and we sort of get all the zoning done, but, it's sort of like put a furnace in and sort of, best. And so contractually, it doesn't lend itself to a lot of tight coordination, because by the time we're already through zoning, the architect is sort of not as involved with the project, and the general contractor is picking up the work, and there's just the ball's not really being handed across, and that's just a function of the delivery system that we've sort of have sort of evolved over time. So it does take some extra effort on the design side to sort of make sure either to somehow in the contract be more involved, or on the whoever, like if the general contractor is doing the house on spec, to sort of make sure that there's some communication back to the person who's submitting the permit. So I don't have a solution. I just know that's the problem.
Sure.
I agree.
Sure.
That's an issue.
Yeah, and maybe is there something that you might see as far as how might there be a good method or mechanism to provide that support as part of the process rather than as an afterthought?
Well, I think in the cases, where you can get the general contractor earlier on the job. So if you're going to have the general contractor do the mechanical, and it's going to be under them, then it behooves the let's just say it's a custom home, okay, as opposed to a sort of a developer home. Get them on board, so as you're submitting for the permit, you have someone to talk to. And they have someone to talk to, and they're submitting the permit. The mechanical contractor and the architect are submitting the permit drawings together and answering those questions that Katie sees are misaligned. Because the architect knows, in general, the architect sort of knows how big the house is. They know kind of what kind of windows are going in. They know the stuff that needs to be on the beginning of the load calculation sheets. And it's not hard information, but it's just, they would need the mechanical contractor needs that, and if they had someone to talk to, it'd be a lot easier. So if they can get that guy on board before they submit for permit, it would make then the compliance piece a little bit easier. But not all jobs get the GC on early enough for that.
Sure.
Yeah, and certainly from a code standpoint, I mean, we can send the comments back that they're not aligned and people correct them, but so often people are in a rush to get started, and then the time frame gets thrown, and then that's where frustrations come into play.
Okay. Next kind of question here is understanding that there is some varying enforcement around the state of Illinois, and I realize that probably not necessarily recognized here in the room at the moment, but looking at that and saying, understanding that there is varying enforcement, how does that change any approach to design, or is that changing the marketing as far as the compliance benefits, of why should a building owner comply, even if it's not really going to be enforced for a particular project or area?
Oh, that's a tough one. So I think that, speaking from the design professional side, in general, most architects, and myself included, will do kind of what's needed to get the job done, right? I mean, we're not getting paid a gazillions of dollars, to do this stuff. And so if we know that a certain municipality requires these documents, and we've worked there before, we'll sort of work to that level. Or another municipality requires lots of documents, we'll work to that level. And usually our fees reflect that because we sort of know the municipalities we work in. And so we know, oh, you know, like I'm in Evanston, right? So I know that if I'm in Evanston, there's a site design review board, and that's going to require some extra hours. Or if I'm doing a house out in maybe McHenry County where it's just a house and there's a lot less city interface. So that's usually built into our fee. I'd like to think that there's a standard of care for all design professionals, but you know, again, the way that we bill our work, it doesn't necessarily align. I think what would be helpful is if municipalities had a little bit more clear checklists or what needs to be on the documents. I think that varies a lot from municipality to municipality, and so if there was a somewhat more, a little bit more organized way of what each municipality needs, because it does vary. You see, there's checklists. And you guys know it. Every municipality has its own sort of building plan checklist, and they're all like slightly different. But if there was we've talked about this in the codes. If there was a sort of a standard format for compliance, then every design professional would know, okay, I've got to put my, my wall insulation, my roof insulation, my window performance, my mechanical system, all on one place, on one sheet. Everybody knows where it is instead of sort of it being all over the place. But the industry's not there yet. The design industry is not necessarily there yet with a standard format for all of that information. ComCheck kind of does it, and ResCheck kind of does it because it's all in the same form, but it's sometimes not easy to align a ResCheck printout with the actual plans and elevations. They don't, they just they don't match exactly. I mean, they match number-wise, but it's not super clear format.
From just a city standpoint, on a residential home, I mean, like you said, every city has different requirements. Some just don't have the staff to look at certain documents. Others will request a document, but they're not going to look at it. I agree that, having a checklist would be very helpful for each city. I think that's a good idea. I also think that just from a city standpoint, we get sometimes, maybe a contractor is submitting for a permit and well, we didn't have to do that in this municipality. We do get that fairly often. Just to understand that we're not asking this to be difficult, but we're asking this to support the energy code. So yes, a manual J may not have been required in a certain municipality, and maybe you turned it in, but maybe nobody looked at it. But if we are looking at it and seeing an issue, we're not trying to be difficult. Again, we're just trying to get compliance and make sure everything is correct.
And from a builder standpoint, it shouldn't matter because we're required to follow the codes at minimum. We're required to follow the EEB Act statewide, even if it's not enforced. And that's, from the builder side. So, having a slight issue with that. It's just also like the design as you were getting to a single sheet. How can you actually give a permit out if they don't have the manual J and all those documents they need to, verify that everything's been done properly up front? It's a little hard after the fact, but yeah, I know. I go out there half the time and people don't have manual J's. They don't haven't even done manual D's. So.
It's the state of Illinois here, as Sean said, as a builder, they're the ones that are responsible for doing the adherence to the energy code here in Illinois. That's the way the law is written, and when they started this with the residential back in 2008, 2009, when they actually came across and did the residential part of it, a lot of places still had CABO, Council of American Building Officials, that they were using, and they were still going to continue using that code. And so that interrupted the International Residential Code. So the lawmakers really went ahead and just said that the builder is responsible for it. And here in Illinois, I've been all over the state on several different grants and things. And it's true. I mean, it's not just here and around the suburbs in Chicagoland, the northwest suburbs. Each different municipality has their only way to look at it, but it's all across the state. You go downstate, actually down by East St. Louis down there, they're very strict on the energy code down there. But you get into Springfield, Springfield actually has an amendment to the code that says they will not do a plan review and they will not do inspections. They leave it up to the builder. So it's frustrating for code officials, and it's frustrating for builders, and it's frustrating for architects. I don't think we'll ever get anything better than this, though.
Okay. Have a question here regarding blower door testing. Looking at having a question here as far as the blower door, is that before or after the occupancy inspection? Should this be, should it be part of the final inspection? How are you guys finding that most municipalities are handling when is the blower door test done?
That's easy. It's supposed to be done before occupancy. I mean, plain and simple. The biggest one between most people is, should I do it as soon as I've got all my roughs completed, or do I wait until I have all my drywall and everything else in? And, that gets down to who's doing the testing with you and what you're actually looking for. A lot of times, most of the builders are going to wait up until a few days before final inspection, and they're going to be, quite honestly, they're going to be fine. As long as they paid some attention to the details that they're supposed to.
As Sean said, we do like to see them before we go into our final inspection, whether they turn them in to us beforehand or they hand it to the inspector. But we do like to see it before we go in for final inspection. Like Sean said, a lot just depends on who they're working with and timing, so coordination.
And I suppose this also brings up a good question as far as when in the process do you bring up as far as that hey, this is required, and the dialogue as far as, okay, this is required. When are you planning on doing it? As Sean indicated, that could be before finish or after finish, but definitely after all the penetrations are made.
Typically during that plan review, we are asking for the blower door requirement to be put on the plans.
Right, and so I think that the discussion should be, like Sean said, what are you trying to figure out, right? From a designer's perspective, or from a kind of a forensic architect's perspective, we like to see the blower door test done before finishes are going in, because the whole point is to identify problems that you're going to have later on, and it's a lot easier to do it before you start putting drywall, and insulation in. That said, it does require someone to say, okay, you guys, we need to get this blower door test in, 6 months before, we're ready to close up, or we're ready to put drywall on. So it does require a lot of planning, but to me, the ideal time is before the drywall goes in, not after the fact, because you want to be able to use the blower door test as a tool to improve the building envelope, to improve that stuff you basically can't fix later. Like once the stuff is built, it doesn't change, and it's really hard to fix. And so we're relying on the blower door test as a sort of an after the fact, but it should be used as a diagnostic tool earlier in the process, ideally.
Okay. Realizing that you know, much construction is on existing buildings. Are you guys finding that there is good understanding out there as far as what is grandfathered under the code, such as whatever you're touching as part of the renovation and alteration needs to be brought up to code, and the existing doesn't have to be modified as part of the energy code?
I would say yes. When you start to get into existing construction, I think you can have a definitely different mindset in terms of looking at certain situations. We do get a lot of calls from architects during construction, just to ask, how would you look at this? And we do encourage those calls to come in, because it does gets everyone on the same page early. We get a lot of calls from insurance companies on house claims, and we battle with the insurance companies a lot, whether it be the homeowner. I'm just going to say, for example, if a roof is damaged during a hailstorm, the roofing is going to get torn off, but the sheathing is not. So at that point, you do not have to go in and update that insulation above. Unfortunately, sometimes the homeowners perhaps want that. Certainly, you can understand that. And hey, if I can get the insurance company to get on board with that. So we do get a lot of calls. And as much as we would love to see that insulation go in too, the code doesn't say that. And so, again, you do, the code is a guide, and you follow that guide. But there are certain situations in existing construction and additions, alterations, where coordination between the architect and the code official is a good thing, and you can come to a reasonable decision.
In general, when we do additions, the rule is, if it's a new wall that we're putting in, we bring the wall up to the prescriptive code level. We sometimes go beyond, or typically we'll do the prescriptive. And any new windows we're putting in. Even if you're replacing a new window in an existing opening, we'll bring that new window up to we'll probably go for the best window we can possibly buy, right? Because that's a great opportunity. The tricky part is, at least where we are in Evanston and Chicago, there's a lot of existing homes that are being gutted fully on the inside. So it's not new construction, but when you go inside, there's not a lot left but a bunch of studs. And so then the real big question is, do we insulate the walls, right? Because the hardest thing to deal with on an existing house is the walls. And ideally, if you're re-siding, that's a gray area if you have to, or you either would or would not have to add additional insulation on the outside. I would say that if you are re-siding a building or re-siding a house, your best savings, because you've already decided to purchase the siding, which is the most expensive part of the wall, is to put as much insulation on the outside of the wall as you can, because that's the best thing that you can do for the wall, and and it's also a very long-term investment. But the code is pretty unclear as to sort of, if you're re-siding, what you have to put back. And we've gone sort of both ways, in that. But if you can, when you're doing a total gut rehab, you should bring the wall up as much as you can. And I'm assuming when you're doing that rehab, you're also bringing the entire mechanical system up. You're basically getting a new furnace, and everything's all sort of coming up to compliance.
Certainly, when you're doing a remodel job, you start opening up the walls on the inside of the existing building, and there's no insulation there at all. The intention is to bring it up to R20 in that area there. But if you do take all the drywall off, as Glenn was mentioning, you start from scratch. As far as it goes, the inside of the house then is a brand new house. You're looking at all around your rim joists. You're looking in your attic. You're looking in the walls. It has to be brought up to what the code is. Otherwise, if you're just putting an addition off on the back of let's say a ranch house or something, and it's an older ranch, 78 ranch, and you only have to bring what you're building up to the code. If you're running any ductwork into that, the ductwork has to be brought into compliance with the code. But you don't go back in and change the furnace, and you don't change the ductwork in the rest of the house. You're just looking at going to the addition out there. But and again, each municipality looks at it a lot different out there. Some get I've talked to some contractors that they've almost had to go through and replace the furnace because the village understands it one way. So a lot of times it's up to the municipality.
But on the topic of opportunities, it's when you do an addition, even though a blower door test is not required, it's probably a good idea to get one. And so if you're going through a renovation, your property's already going to be a little bit messed up, right? You're going to be having contractors traipse through. You're going to be doing a little bit of work, and it's a great opportunity to do a blower door test to see if there are some big holes in the existing portion of the house that while you got some people out there who sort of have tools and drywall and caulk, the additional cost for them to go fix those holes is extremely minor, but the savings are huge. So if you are thinking or you are working on a project where you're doing a renovation, you should strongly suggest to the owners to just, Sean, what does a blower door test cost? It's like, what, 99 bucks or something?
300, 250, 300.
And it's well worth it.
Agree, but the catch is, the code does not require it. And just to clarify one thing Don did say, if you open up all the studs in the wall, you are only required to fill the cavity. You do not have to bring it to R20 or anything else. So, I mean, I like saying the codes are black, the codes are white, and there's a whole lot of gray. But that one actually is pretty well spelled out on there. And yeah, I agree with you on the siding, but there's nothing, unfortunately, that says you have to. Is it good practice? Oh yeah, it's a really good practice, but it's not required just yet.
And we get, I can't tell you the number of calls in the last year I've gotten with, again, hail damage and the insurance company asking, do I have to put the fanfold insulation on the outside of the home? And the answer is always, we would encourage you to, but no, it is not required. So, and as for the blower door test, if somebody has a note on the architectural drawings that maybe they took the general notes from a different job and it's on this addition job saying that the authority having jurisdiction is going to require the blower door test. Normally in a plan review, I would state that you're more than welcome to do the blower door test, but we are not requiring it per code.
And this definitely, is I believe all our panelists have kind of touched on as far as understanding, code minimum is the minimum not to fail. There are definitely good practices and definitely ways for building owners to gain substantial additional value beyond just doing the bare minimum, and it is a good investment, and even especially on the envelope, understanding that furnaces will be there for 15 years and things like that, and you'll change out your kitchen who knows how many times, but when you do something for the building envelope, frequently that's going to be there for a long life of the building. If it is ever replaced, it'll be 30, 50, 75 years that's going to be able to last. So
100. We're working on buildings that are built in 1890 that have, haven't been recited. It's awfully interesting what you find inside the walls in houses like that too.
What newspapers and what year? The 1910 Chicago Daily Herald or something. You mentioned caulk. For air sealing, probably the cheapest thing you can do is to just get a good couple cases of caulk and just go through the house. When you go through for your rough inspection, you should be looking for how they're sealing. Are they sealing at the plate? Are they sealing around any joints that you see? Biggest problem, I think, on the exterior of it can be is the air barrier itself is not put on in accordance with the installation instructions. So, they can just staple it on and, as opposed to the way it's supposed to be put on. So air barrier and then just going on the inside and caulking can really make a difference when you do that blower door.
yeah, let's move a little bit over to ventilation and things on that side of things. Had a question come in specifically for Katie and Don as far as looking at. Do you guys have any best practices as far as getting design professionals to indicate the method of compliance for mandatory ventilation? Positive, negative, or balanced ventilation.
We do get a handful of homes where the ventilation isn't called out for. At that point, we generally will ask for a statement that, one, the ventilation will be required and what method are you going to use. We do see a lot of just exhaust fans, just from a builder standpoint. That is the most inexpensive way to go about it. Is it the best way in our climate zone? Not necessarily, but again, it is acceptable. So we do see that done a lot. As the houses get more custom, I would say we get into the ERVs, in which it's detailed and thought about much further. So a lot just depends on the home, the purpose of what's going in, whether it's a spec home, a custom home, just in terms of the value of the home. But the mechanical ventilation, certainly we've come up with just a standard one sheet PDF that we can hand out to people that just very briefly describes the possibilities and the way to go for the people that don't know anything about it to make their educated decision. But certainly we've seen mechanical ventilation all over the board, so.
That's very true, Katie. Actually, if you call the International Code Council and you ask for an interpretation and for ventilation in there, they will go along and tell you that you just have to put a fan and run it, 24 hours or with your on-off part of it in there. So Ryland was one of the first ones that we worked with ventilation, and what they did is they took their cold air, the duct at the far end, and they opened up with, they added the air in at that point, and by the time it got to the furnace itself, it tempered itself enough, but it got enough outside air to be able to work very well. And I think they still do it today, even though they've changed their name around a few times. But it's one of the easier ways we've seen. Honeywell's got about a $150 fan that you can put into that, and it'll work with the on-off with your furnace going back and forth. So there's a few things that are out there, but it can be difficult if you work with somebody that has never done it before.
I think it's also maybe important to mention too, on additions, if you're doing a finished basement, at that point you need to introduce mechanical ventilation because most likely you don't have the proper light and vent in that basement. If you're remodeling a basement from a house from the 1960s, that house probably breathes pretty well on its own. So, if you're putting a bathroom in that basement to put a fan in, it's probably fine. Whereas if you have a house that was built 5 years ago, well, hopefully it already has mechanical ventilation, but maybe it's a tight house. You do want a better system to help that house breathe. I think with COVID especially, I think everyone's become a little bit more conscious about ventilation, so.
And along those lines, have you guys observed any or been seeing any commissioning of the ventilation systems being required in residential as far as, okay, I put in 100 CFM fan. Is there any testing to verify that I'm actually getting 100, by the time it's gone through the spaghetti of ductwork between the fan and the outside?
The short answer is unless an architect specs it or they're after like Energy Star, Passive House, or something else like that, no, nobody's really testing it. It's not required, though that is being popped in the 2021 ICC, as I recall. And as for the testing, yeah, I've done plenty of Energy Star and even some builders actually who did care. Most of the time, 100 CFM fan, you're going to be lucky if you're actually blowing 50 CFM out. Just because of that spaghetti wire and everything else. So when you have the HVAC contractor out there and they start seeing what the numbers are and what it takes to fix it, things start getting better. But for the most part, yeah, they all fail dramatically.
Have you observed any best practices as far as labeling of ventilation systems or occupant training? Things like the control is a switch on the wall and someone's actually put a label fresh air on it or something where it's like, oh, that switch actually does something. So to prevent or dissuade occupants from just turning it off saying, oh, it's too costly to run. Have you guys observed any good practices you want to help bring forward?
From the code standpoint or the municipality standpoint, it is not something where we often are in touch with the occupants of the house. Generally, we're in touch with the contractor, so we can only encourage them to have that conversation.
Yeah, the one.
Go ahead, Len.
Oh yeah, I'd just say the one project I've had, it really the training fell onto the contractor installing the system, and this was this also had geothermal, so it was sort of a little bit of an involved mechanical system, but yeah, I mean everything's just kind of in the basement. There's no labeling, and luckily the homeowner was he's kind of a hands-on kind of guy, so I think he was okay with it. But yeah, I would think that if it was a homeowner that was sort of not as hands-on, they probably would have been if something went south, they might have been a little bit confused.
And actually, I can say most builders that actually do have a standalone ERV, they forget they even need to have a switch there, or much less label it. I mean, that is one I overlooked all the time. And the other ventilation one is generally, as I said, is the bath fan. Most homeowners can't shut it off because that one is set up directly up there in the roof. So unless they pull down the cover to clean it and go, oh, what's this? It's always going to be on for them. But builder teaching the homeowners and outreach, it gets down to, if they're following, above grade programs. A lot of them don't do it. So unfortunately, there's nothing in the code that says, hey, you actually got to teach the homeowner that, this is this and this is that, and this is why it's important.
Okay. Well, let's kind of swing back around here and touch on a little bit of envelope and building tightness, and had a question come on in as far as windows and doors in the fenestration package. For particular building for building departments in particular, is it helpful to have a schedule printed ahead of time and submitting that as part of the uh, building package for review? Uh,
I would say not necessarily from a prescriptive. I think if you're having it as a separate package from the drawings, it's always apt to not match. And so that becomes an issue. We want everything, whether it's on, the permit application or if it's on the drawings or the manual J, if you're using R20, it needs to be R20 everywhere. But let's say there is a job doing a performance house that, R20 may become R13 or a combination of different R values lower than the prescriptive. And so again, it has to coordinate across all those documents. So, I mean, certainly if you wanted to put something with all the R and U values in a separate package and turn that in, it would be looked at. I don't think it's necessary though. The drawings and the manual J, the run rate, they would all stand on their own. So, and we would expect them all to match. So if there was one document that said something different, we wouldn't be able to accept that.
Yeah, we like to put it on the actual drawings, just because, again, everything really, the only thing that the contractor tends to carry around the job is the drawings. They really don't carry anything else around. So if there's anything you want on the job, you need to put it on the drawings. And it's not that complicated, right? I mean, you got windows, walls, and roofs, right? That's kind of the three really big things that you need to have on there. So it's not a lot of big numbers. It's not a big table. It's pretty straightforward, just from the envelope, from the physical side.
Okay, so it sounds like it may be helpful for the fenestration to put that package together and make sure that it gets to the to the designer, just so that way it's like, okay, here's the table, so that it gets onto those prints and verify that, hey, that does match, or that, vice versa, where the table on the prints, okay, this needs to go off to the fenestration people to make sure and verify that what they're providing is matching that table, that as designed.
I would say that, there is a window schedule that's supposed to be on the plans. And on that one, I mean, you should just simply list that this is the U value, it needs to be match this or be better. Because, I mean, you can have a window that is off by 1 inch different size, and that U value goes either up or down. So, I mean, you can't say, hey, this window's got to be 0.27, this one's got to be 0.25. It's just, hey, these should all be 0.25 or better, or actually 0.30 or better. Because in the end, before they do their final check anyways, the inspector is supposed to go around and actually verify that against the windows. What's actually on that window sticker on all of them. And they're actually not going to check it off the plans. They're just going to make sure that window meets codes. So.
Okay. So we kind of move into building tightness. Had a question as far as, Sean, I know you do blower door testing. Do you guys have any good resources as far as, for builders or homeowners around the state of Illinois? Are there good resources as far as how to find people who do blower door testing?
You can easily just Google it, blower door, and then your city name, and I mean, it should pop up a whole bunch. Though they are theoretically either supposed to have gone through a DET class, ResNet HERS Rater, or I think also some of the BPI ones are also allowed. I think those are the only 3 allowed in the state. Dan would probably know that one better than I would. So I would definitely check the certifications too, along with that line.
Brian, when DCEO was with the energy part of it, they had actually on their website, you could get in and for the training, you could see who the people were that were trained in the Illinois area. CDAC, does that follow up on your part? Do you keep track of whether the BPI or if they're ResNet or anything?
I don't believe we have a particular listing of providers out there for that. So maybe that was something that DCEO had it, and it didn't get handed off as part of the handoff to IEPA. So as far as our building envelope and testing, are there any particular features that you're observing in homes that test unusually tight, and how tight are you finding some of these high performer buildings?
Lynn didn't want to go forward, huh? Actually, the biggest one is the builders actually paying attention to the details. I mean, there has been a air sealing checklist in the code since 2006, 2009. I mean, just following that automatically can easily get any home builder below 3. I mean, I did a presentation back in 2015 where I looked at the ones that fell underneath 2009, 2012 codes. 75% of the houses were below 3 air changes already. And that was back in 2015. I don't think the numbers really have changed that much on that one, though. I think a few might have gone tighter, but others just kind of coast. So, following that's the first one. Then you can go, I mean, if you really want to start upgrading it, go to like zip wall sheathing, liquid applied membranes. I mean, all that stuff helps. But it gets down to somebody actually paying attention to those details. Don't send the newest guy that could care less with a caulk gun out there and say, go find all the leaks, because they're probably not going to want to. You got to find somebody that's actually detail oriented that will look.
I mean, from the code cycle or the code perspective, there is a lot of incentive to decrease that to get the target number down. And I'm trying to remember what's in the 2021 IECC. Is it still the 3 air changes per hour?
It's
what they got through the last code cycle?
It's 3, but there is some exception now allowing almost anybody to go up to 5. I cannot recall the exact exemption on that one, though. It's kind of flaky.
So on the commercial side, we're getting down to, well, we do CFM per square foot, so it's a different metric. It's surface area, but the next commercial code cycle is pushing it down tighter, and so I'd have to find out what the equivalent is for residential. But there's a lot of push to get it tighter because it's relatively cheap energy efficiency stuff. As Sean said, it's paying attention. It's not necessarily more stuff. It's just better quality. And there's huge savings. I mean, just huge savings.
I believe they're with the 2021. I believe they stuck with the 3 air changes per hour. I know here in the state of Illinois, presently under the 2018, there's an amendment that raises that to 4. And Sean, I think you mentioned the backstop provision that they added to the 2021 IECC that said even under the performance path, you can't go above 5 air changes per hour. Whereas before, you could potentially just have a 7 air change per hour, but you gotta make up for that performance somewhere else. So I think in the 2021 they've added a backstop so that it's 3 under prescriptive, and if you're doing performance, you can't go above 5. So you can't just go crazy on air leakage. But yeah, that's where I wasn't sure how tight, because you've our panel so far has alluded to, a 3 ACH home is really not a very high bar. So I'd be curious of our panelists, what are some of the lowest scores that you have personally seen on projects?
I've seen a few of the passive house ones that easily come in below the 0.6. There's one builder out here I know that he would be highly livid if he ever got above a 1 air change. And I mean, he just uses standard practices. A few of the other friends and people I've talked to, I think somebody was down to like 50 CFM for the entire building. I can't even remember what bloody percentage that was, but it was low. So.
Yeah, we tend to shoot for around 1.5 without any major modifications. And then, yeah, if we're starting to do passive house stuff, then we're getting down below 1. But I think most projects could get to 1.5 without a lot of major modifications. And that should be a great target for people to shoot for, if not 1.
I do think it's interesting what Sean said. I mean, a lot of builders, I mean, the craftsmanship going into it really does count for so much. So if you go the performance route and maybe you are spending less on wood because you're going 24 inches on center instead of 16, and you go down to an R13 instead of R20, but your craftsmanship is superb, you're going to still get those slow air changing. So it is, how can you, the construction portion of it, it really is interesting how they can play together to make a successful project for everyone in terms of cost and in terms of energy efficiency.
I see one out here from Robert. He says, for exemplary examples. I actually have a blog site out there, theHTRC.com, where I've got some of them. But another one I'd actually point to is Energy Star, or what used to be the Building America site. They actually have some best practices guides out there with pictures and how-tos and everything else. I would definitely look towards that site.
You can go to the building science, the Joe Steebrook site.
Buildingscience.com.
Buildingscience.com. He's got a lot of great case studies. They're pretty well written articles, nice details.
Okay. With the buildings becoming tighter and tighter, is that causing issues for fenestration or condensation on fenestration? And are there certain practices that need to be looked at as far as in the field? And because I don't think, at least the energy code, I don't know, deals much as far as condensation. I don't know, that may be more of a building code issue. But yeah, as far as condensation, are we seeing that a lot more in the field?
So do you want the scientific answer or the real answer? So the scientific answer is if you decrease air leakage around the window frame, you won't get as much condensation because the window's not going to be as cold. You're going to have some condensation due to just the U factor, the sort of the surface temperature of the glass. But with double glazing, it has to be pretty darn cold outside and pretty warm, pretty humid inside to make sort of that happen. The reason people get condensation on high performance windows is because they're leaky around the perimeter and you're getting cold air that's super cooling the inside surfaces of the glass in the frame. So again, it goes down to air leakage, not so much the window.
And I will also add, it goes down to how the homeowners use the place. I mean, if they're cooking without running the exhaust fan and that's producing moisture, you're going to have condensation. You're not running a bath fan, you're going to have condensation. Find out what the issue is. One of the other biggest ones, do not ever, ever, ever use a ventless fireplace. because the major byproduct is moisture. So, if you're getting condensation issue, find out what the cause is, because it's probably not the insulation. It's probably not the windows. You need to find out what the problem is.
I did have one when I was building. I had, they complained about a lot of condensation on the windows, and we had done pretty good just before the energy code. And we did a really good job of building it. And I had Anderson come in. Yeah, they actually, with their little machine, penometer, whatever, they came across, and they found nothing. And she called again, and she was upset. It turned out that she was cooking a lot of spaghetti and a lot of things on the stove over there, and had all the burners going, and she'd get a lot of condensation off that. So as Sean says, it's the people on the inside a lot of times that can do it. If you have a lot of showers, a lot of other people, or even big dogs, sometimes you get a little bit of extra condensation into there.
And I wonder if part of this also goes back to our ventilation system that we never tested to see, are we actually, getting that humidity removed? Yeah, definitely for those high sources of humidity, but even just from building occupants, or are we getting that removed from the building and sent outside too for the winter? So. As far as increase, as we keep getting tighter buildings, are we seeing problems on the HVAC side as far as, sizing of equipment and ductwork, and what problems is that causing? Are we reaching limits where, trying to size HVAC systems and trying to source small enough equipment is becoming a challenge?
So I think I can say from a review standpoint, we often see oversizing of equipment. We very, very rarely see undersizing of equipment. And I think there is still a mentality out there that the bigger, the better, which is not the case. As people start to understand the Manual J and how it functions and how you're looking it from a scientific standpoint, it does get easier to have people accept that, no, that is the correct size equipment. But just as a whole, we tend to see oversizing still happening.
And I would mention that the Manual J is generally going to give you an oversized piece of equipment anyways, especially, when their tightest, limit they have on there is one that's basically a code built house now. Most people don't say, oh, it's super tight. It's average. No, it's super tight. Trust me. And yeah, it actually is becoming an issue. ACA is actually working on a low load house manual coming out, because the problem is even if you can find a piece of equipment that's that small, you're not getting enough airflow going to those rooms. So they're looking into that to some extent. Your biggest thing is you're probably going to have to go with a variable speed unit for a lot of these houses, in order just to get the proper airflow, so they're not just kicking on and then off because they've already reached it. I mean, shoot, passive house, they're saying was, we could basically heat your house with a hairdryer. Okay, size me a piece of equipment like that besides a hairdryer, because electric resistance is not allowed. So.
And the other thing that we've run into with equipment sizing is, the one thing we've talked about is if the equipment's too big, it's not going on enough, and it's not dehumidifying because it's basically not going on. But the other thing that we found that I never would have thought about is in a residential house is stack effect. So this was a 3-story house, and again, it was ground source heat pump, so it had sort of just a little bit of ventilation. But I was surprised the humidity difference between the basement and the 3rd floor. I mean, this is like something you think about. Stack effect as a commercial building problem, right? It's a 25-story problem, right? Large buildings. But even in a 3-story house, there's a lot of air inertia that the air has to overcome to sort of just move to travel up, 3 stories via ductwork and friction loss. And so, a big house, you'd be surprised how little air movement you actually get between the floors. It may be different on a ranch house, or a smaller house, but, on a fairly larger house, ducts can get pretty complicated and you end up not having the airflow that you expect at all. And so there's some definite, the rules of thumb really work with that. And that's where, you may need to, if you are doing a house that is larger, then you may need to you can't just rely on rules of thumb, and may need to sort of do a little bit extra work somehow. And maybe that is partnering up with a mechanical contractor, and the guy doesn't want to work for free, but paying him for some design services. I mean, that might be some of the best couple $1,000s you'd spend, rather than just relying on it in the field where he's already bid the job. He didn't bid any design time in there. He's just going to put it in. So it's like, we can get a better, again, going back to that original conversation about getting a better relationship between the designer, which is typically an architect that doesn't know a whole lot about mechanical. I mean, I'll be the first to admit I'm not a mechanical engineer, and the installing contractor. And, those guys have a lot of knowledge, and getting them early, throwing them a couple bucks, so you can get everything square, and then you have a high performance house that works.
And it's interesting, you mentioned those rules of thumb, and I wonder that how many of those rules of thumb, as Sean kind of mentioned on the Manual J, are based on an average leaky house, which you cannot build that anymore. That's not code compliant. And so, yeah, how many of those rules of thumb are just no longer, you just cannot use them anymore.
I remember down south when I lived down there, the rule of thumb was 400, 500, square feet for a ton of air conditioning. Nowadays, that, if you were to follow rule of thumb, you're about 1,500 to 2,200 square feet. When you start doing the proper sizing. So.
Yeah, and that's something that's quite remarkable. I know, just this last year I had my HVAC unit replaced. 1920s house, which has been insulated, but had to encourage the installer to downsize the unit, and the thing's still too large. I don't think I'm up at that 1,500 square foot per ton, but I'm definitely even in a 1920s house with some insulation, I'm definitely in that 1,000 square foot per ton realm. So yeah, and I'm sure this house didn't have anything particularly special when it was built. So yeah, that's definitely something. As far as insulating and things like that, are you guys seeing during equipment replacement, are you seeing any downsizing of, is it typical for units to be downsized when they're replaced? Or is it just, well, there's a 3-ton there, just put a 3-ton back?
Ryan, I can tell you, the municipality I'm at, we do not permit replacement equipment, so I'm not able to comment on that, but we certainly get a lot of calls, which is encouraging that people are thinking about it. And when we replaced the equipment at my house, which is a 1960s house, we had much the same problem as you did. Everyone wanted to put in the larger equipment, which we did not go with, so.
Yeah, I'd say that one's going to be hard to answer, especially seeing Illinois amendments basically say, you don't have to test any for this. So I hardly see any too much of it. I mean, one thing to remember, you had an 80% efficient furnace and now you're up at 95, you're getting 15% more BTUs out, so you automatically have to downsize just for that little factor. But no, a lot of times, they go, do you have any comfort complaints? Nope. Okay, I'm going to swap it out with what you had before. Oh, you have comfort complaints? I'm just going to bump you up. I mean, that's the standard one I see when I actually go out to help homeowners with their existing energy problems. So.
And you probably find that
I
part of
think
the issue
most,
there is just from cycling on and off causes your comfort complaint.
For replacement, as Katie said, well, most of the municipalities are out there in the suburbs actually do require a permit for replacing an air compressor, or your furnace. But I doubt if any of them actually ask for any kind of paperwork on it to see if it's going to be the right size. And the biggest thing we see, though, is when they take that 80% furnace and they replace it with the 96 and they orphan the water heater out. That's the biggest problem that we see.
You mean where the water heater no longer can provide enough lift in that chimney, and so you end up with condensing in that chimney issue?
It just won't draw. So what a lot of, the HVAC contractor may come out and say, now that we're changing this from an 80% to a 96%, we're going to have to drop a stainless steel liner through here, and it's going to cost another $1,400. Well, yet another HVAC contractor that comes in and says, oh, we don't need that stainless steel. We can do it for $1,600 less than that guy did. Well, the problem is a lot of municipalities don't catch that, and that's a problem. And if they don't get a permit at all, the homeowner's the one that should be ashamed for that.
Yeah, that was something that I did consider as part of my upgrade, because I went from probably a 50% efficient furnace up to the 90 plus, but I also knew that that water heater went into that same chimney, and so as part of the plan, not immediately thereafter, but part of the plan was a few months later, swapped out the water heater and went to a heat pump to just eliminate the need for the chimney completely. And I've since pulled both chimneys down to say, I don't need any more holes in my building envelope while I'm at it. Let's go ahead and take care of that. Speaking of additions and modifications and renovations, I got a couple of ones that we frequently have come up to us and saying, okay, what might your thoughts and approach and recommendations be as far as people? I know a lot of people have these sunrooms and things like that, and they want to add a heater or fireplace. What might be a good your approach or recommendation for homeowners who might be wanting to consider that?
So is it a sort of uninsulated sunroom that they want to make into a sort of like a 3-season room that they maybe want to make into a 4-season room? Sort of that kind of thing?
Yeah. I just got a nice sunroom on the back of my house that I use occasionally, and it's like, it'd be nice to add some heat into this room.
So yeah, you could, but if it's uninsulated, you would just be heating the outside. I mean, at the end of the day, if you've got, happens in Chicago all the time. There's like porches all over the place in the back. At some point in the last 30 years, someone enclosed them, And then the new homeowners are like, hey, it's an extra room, and they want to like put a TV back there, and the next thing you know, they want to spend like all this time back there because it's a pretty cool room. But it's basically made out of wood with some pretty crummy windows. And yeah, you could put a heater back there. It's not legal. That's the first thing. But you know, it depends. Yeah, it's always going to be temporary, and so the best thing to do is to just have some temporary heat. If you start making things more like official, it's illegal, and it's just not a good idea. I guess if you're doing a real addition, then that's a different story. Then that gets back to, you know, insulate it, make it a real addition, shade the windows in the summertime so you don't get excessive heat gain, and get high performance windows because you're going to have a lot of glass so you don't lose heat in the winter.
As he mentioned, you're just heating the air. Yeah, in that case, you know, it's the same thing with all the tents we've got going up right now. You basically use an infrared heater. That way you're heating the person or the objects, not the air itself. I mean, that would be the best way to sort of do it that way. Fireplaces, yeah, good luck getting that through the codes. But yeah, I like fireplaces. And I mean, even now the EPA basically requires them to be a complete direct vent. So you're not even pulling in the air from inside the house or anything else. So I really don't have an issue with fireplaces, especially if the power goes out.
So I'll say from a code standpoint, we get a lot of, I'm going to say, additions for 3-season rooms, and whether they do slab on grade or whether they're elevated. And at that point, they'll put insulation in the walls, and they'll put insulation in the roof, but they're not putting insulation per code. Well, they don't need to, they're not heating it. But as they do that, you also know that at some point in the future, you're going to want to heat that. And so, you know, the most we can do, again, we can't make them do anything. What they're saying is what we take their word for, but we would put a please be advised note at that time. You know, if you're going to heat this in the future, should you put the slab insulation in? Yes. You know, should you put the R20? Yes. But again, they make their own decisions at that point.
The 2015 International Residential Code actually came out with one section in there that there's 5 categories for screened 3-seasons rooms out there. And it starts off with just having in the back part there with screens on it, no insulation or anything. And it's just like you keep the mosquitoes off. And it works up to number 5, where you're actually you can have the doors open between your thermal break between the sunroom and the house itself, the conditioned area over there. So you start off with somebody doing like that. But as Katie says, somebody wants to go ahead and put heat in something that's been there since 30 years ago or so. You can suggest it to them, but it's a difficult thing to do. But the IRC is very strict now. Every time you come in for a permit for a sunroom, you actually have to put down on the permit what category you're planning to build that to. So, and I do work with some people that and suggested to them to put, like Katie says, down for the foundation part to get the insulation in the slab part down there. So later on, if they decide to go ahead and finish it off, it will be energy efficient possibly.
Yeah. Another question here that's come in. Looking to see what do you recommend as far as an insulation strategy for renovating an old home? Noting that the potential pitfalls with spray foam, you know, making sure that it's properly curing and things like that. Do you go open cell or closed cell? and yeah, a concern particularly for older fireplaces, where, yeah, it's just basically leave your window open all year long. So, I guess let's start with, insulation strategies as far as renovating an old home.
So going back to the question is as part of that wall, are you able to insulate on the outside? So let's just say no. Like, again, typical Chicago bungalow, thousands of them across Chicagoland, brick veneer on the outside, some black tar paper that's the drainage plane, and actually is really good because it seals up and it breathes when it needs to. Some type of sheathing, maybe it's boards, and then you've got some 2x4s on the inside and some newspaper or some stuff. Okay, you rip off all the dry. I'm assuming this house is a gut, so you ripped off all the drywall. Now, as we already talked about, you're supposed to fill the cavity. You don't have to. You beef out your studs to put in, to make those 2x4s, kind of fur them out to your 2x6s. So you're stuck with a 2x4 cavity. And you can only stick so much fiberglass in that. I would go with spray foam, and, because you're just going to get so much more R per inch than you can with the fiberglass. And I would also go with open cell because you want it to breathe. You don't want the closed cell is going to give you another vapor barrier, and you don't want that. You want it to breathe. So you want to go with open cell, and yeah, you got to let it cure. And foam is foam. So there's a whole discussion about foam, but open cell foam in the cavity, you're already going to put some drywall on, so that takes care of the thermal barrier, and that's probably the best you could do without replacing the siding on the outside. You still have to deal with the window transitions and the window openings, but for the bulk of the wall, that's the right strategy. If you have brick veneer on the outside, the fireplace, I'll let somebody else deal with the fireplace ventilation piece. Again, I'm not a mechanical engineer.
Well, my answer for insulation is it depends. There's a whole host of factors that go into it. You can have a super high-performing house with fiberglass insulation. You can also do it with closed cell. When you start getting into arguments, open cell versus closed, a lot of times it gets down to people's budgets, except for in two cases. Anytime that water may be involved. Basements, crawl spaces where water may come in, it better be closed. The other one actually is also if you're going with a hot roof system. I know plenty of people have used open cell, especially down south, and they're paying for it. And they will continue to pay for it because it holds vapor, especially when you have stack effect issues too. Because that humidity just goes up there, the open cell sucks it up, and then it releases it. I've seen attics up to 80+% relative humidity just because of that. So closed cell, only time if there's a water issue, and then if not, you can generally go with open cell. Fireplaces, leaving a window open all year long, fix the bloody damper. Put a chimney pillow in there. It's a little inflatable thing that fills up the cavity. That takes care of a lot of the issues right there. When you go to start it, the old Rumsford ones, yeah, you've got to crack that window to get it started and get the stuff flowing. But as soon as that thing is going, it only takes about 20 CFM of air. Your clothes dryer takes 200 CFM of air. So, yeah, I can understand where you're coming from, leave a window open, but that's not really the case. So, and style and types of fireplaces, yeah, good luck, call a designer, sorry.
Oh, yeah, and I agree with Sean. On the roof, I would do either. It depends if you're doing a conditioned. It depends on what you're doing with the roof, but you could either do, assuming your ductwork is in the conditioned space, you could do blown-in fiberglass or cellulose in the whole attic space, or if you're re-roofing, you would do the insulation on the outside, do a couple layers of foam, and then nail everything through. Or if you we're doing a cathedral ceiling, yeah, then you know, my favorite is the dense packed cellulose, to pack that in the cathedral ceilings. But it kind of depends. There's a lot of different roof scenarios. But you know, if you do the attic insulation, again, typical Chicago bungalow, typically the attic is an unconditioned attic. You know, just you could fill it up with blown in cellulose, and that's going to give you an R40, R50 ceiling. You know, it's pretty good.
I'm going to say from a code perspective, yes, we see designs from one end of the spectrum to the other. So there is not necessarily a correct answer. It really is what's best in terms of the design of the house and the budget. And certainly if you have an older home, it's going to be tremendously more efficient than it was in the past. So I think most homeowners do delight in that fact when they're done.
All right. Well, we're coming up on time here. So again, I do want to thank all our panelists for joining us today. Just again, if you do have any questions regarding the, or need technical assistance regarding the Illinois Energy Conservation Code, feel free to reach out to us, energycode@cdac.org. And do want to note about our two other expert-based panel items coming up here. One on the 24th of February, case study and lessons learned, and June 15th for the Commercial Energy Conservation Code. So again, want to thank everyone for participating today, and everyone have a great afternoon.
Thank you.